Good evening, everyone. I'm Anoop Singhal. I work at NIST in Maryland, and this is a joint work with George Mason University. The two co-authors are Coco Liu and Professor Duminda. I'll talk to you about a network forensics model that we are developing for evidence analysis. Okay, so here is a brief outline of my talk. I'll briefly describe the objectives, then a brief description of an architecture of our system. I'll show you a small example network on which we've applied this model, some experimental results, and then what we are doing in the future. So the main objective of our work is to develop a formal model and also a software tool that can reason with digital evidence. And the idea is to basically reconstruct attack scenarios from IDS alerts and other events which are logged. So the main challenge here is that some of those alerts may be false positives, or some of those alerts may get deleted by the attacker. So how do you reconstruct the attack scenario even when these events get deleted or the alerts are not complete? So this is a brief architecture of our system, and the core of our system is the Prolog engine, which has all the rules about different kind of attacks. And the different inputs to the system are the evidences, which are scanned using an oval scanner so that they come into proper format. We store them into the analysis database. And we also have an anti-forensics database, which basically has information about what kind of things the attacker does to delete the traces. And then we have information about all the interaction rules, security policy, and so on. So using all these inputs, we collect all this information, and then the output is the attack scenario, which can possibly be the way the attacker was able to attack the system. Okay. And our implementation is basically based on extending a tool called Mulval. It's a Prolog-based tool. And some of the extensions we have are like we use evidences, and we use MITRE's oval format to extract to convert the evidences into proper records, which can then be used to do the attack analysis. And also we have an anti-forensics database, which has information about what kind of things the attacker could have done to delete the traces. So just to show you an example, this is a small example network on which we have applied this model. And there are different kind of ways the attacker can come in. One is using a SQL injection attack, or he could use a cross-site scripting attack, which is a green path, or he could use a buffer overflow attack and then come to the database server. So basically the attacker is trying to access the information in the database server. So he's basically using these different vulnerabilities to exploit them and then to reach the database. Okay? So using this, the rules and the information about the alerts, we can come up with the initial attack scenario. That these are the different attacks, these are the different paths through which the attacker could come in, depending on the vulnerabilities the system has. Okay? But the problem is that some of these attack scenarios may not be correct because some of the alerts can be false positive, or some of the evidences might have got deleted. So therefore, for forensic analysis, we need to put in some ways for the analyst to do some what-if kind of analysis, and also to take information about if some events have got deleted. So to do that, you need to do some hypothesis and then validate those hypotheses. So for this particular case, we have taken some expert knowledge to enhance the attack graphs, and The second option is to use an anti-forensics database, which basically has information about different techniques the attacker can use to delete the traces. So using these two different inputs, we can enhance the evidence graph, and you can see the red paths, which are basically some enhancements. So we have some papers in this area, and I have a homepage where we have put those papers. So if you are interested, you are welcome to take a look or talk with me after the talk. Okay, thank you.